Right. Okay, well, we're back again and we fixed the crazy string that was all twisted. And so let's continue. So we were at, let me grab my paperwork. So we were at this point here where we were doing our different lengths and we'd done 15. So let's go to 50. Let's do our second length at 50. And so I'll just kind of hold the center of mass here at 50. And I'll adjust it to 50 and tighten it up. Okay. And let's continue. So I'll pull it to one side and let it go and restart and say, all right, let's go and ready, begin. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. 14.50 seconds. So write that down for 10 swings. And then, of course, divide that by 10. So, that would be 1.450 seconds. And let's try the next length, 75. Okay, so I'm going to hold this. Put the center mass at 75. Pull this down. And, oops, now I pulled it out. Pull it down to there, 75. Clamp that. Okay. And pull it to one side. And reset, and let's see what we get for 10 swings. Okay, ready, start. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so 17.66 seconds. So clearly you're seeing it is changing, unlike the first two we did with the mass and the amplitude. And again, that was what we were supposed to observe. But this one, you are supposed to observe that it is changing. But it is not proportional if you look at those. So as we increase the length, we've increased the time, but not by the same factor. And that's what you're supposed to notice when you start doing these graphs. All right, well, let's go to the next one, 1 meter. All right, so I'm going to come over here and hold this at the end of the 1 meter stick and loosen it. And see if I can get myself 1 meter of length right there. Clamp it. Okay, and so here's a meter. I'll let it go. And so let me set up my watch here. And so when it comes all the way over, I'll start it. Okay, ready, start. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 20.41 seconds. So again, write that down right here, 20.41 seconds. Divide that by 10, and again, hopefully you're seeing the time change and go up. All right, now even longer still. Let's do 125 centimeters. And so let me find the 1 meter and the 25. Here it is. And let's see if I can then set this for 125. Okay, good. And so there's our 125. Let me reset it, give it a little nudge. Okay, and here we go. When it gets all the way over, I'll start it. Ready, start. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, 22.91 seconds. Again, 22.91 seconds. So again, write that down for the time for 10 swings, and then we can write for the period for 1 swing. And then finally the last one, and I think you are beginning to see that the numbers are getting bigger, but I don't think the pattern's real obvious. It's definitely not proportional, but that's what hopefully you're going to look when you scan those numbers. But let's do the last one here at 150, and I hope I gave myself enough string. 150 is right here. And so let's see if I can, and I think I have just enough string right there to make it at 150. Okay. And just enough to keep it off the bottom. Good. We're going to just make it. Afraid we might have to reset. And then that's do 10 swings again. All right, so I'm going to pull it over and let. There is a part here that says, make then a prediction of what would happen if your pendulum kept getting bigger and bigger and was eventually 300 centimeters. Now notice that I do not have the capability to get there, but I'll explain that in a second. But what you need to do then is to turn to page 49 and 50. And you are asked to make a plot then of the period versus the length. Now, let me just point out that you are not asked to plot the first two. Hopefully the pattern was so obvious that you see it. You have a couple things in your discussion questions, so I'll let you answer the discussion questions. But the reason we're not plotting anything is hopefully you can see, as I already said, that the period did not change with amplitude, and the period also did not change with the mass. But it is changing with length, and how it changes isn't quite so obvious. So you are asked to make two graphs. The first is regular graph paper, and so go ahead and use the data from this third experiment, length and period, and put them in here. You got period on the vertical axis, and you got length on the horizontal axis. So go ahead and just put those numbers in. And what you'll begin to see is it has a little curve to it. And so that means it's not proportional. Remember, we've been talking about being proportional when they were straight lines. And this will definitely show you it's not proportional. So in order to make a better prediction, you are asked to plot this data on what's called log graph paper. And so this graph paper takes the log for you. And what you will see is when something is raised to any power, and in this case it's a square root, so that's a power of 1/2, they become straight lines when you plot their logs. So don't get your calculator out to take the logs. Actually then just put in the value from 15 centimeters to the 150. But as you put them in, you'll see a nice straight line. And so continue that straight line out to here where it says 300. And so at 300, that's how you're going to make your prediction. And so you're going to draw the line out and see what does it read here on the graph. And just as a helpful hint, because we're doing something online here, hopefully when you draw that line out, the period of the pendulum at 300 will be around this line right here, 3.5 seconds. Because I've done this so many times, I know that that's where the prediction should be, around 3.5 seconds. And I also know that's really where the true value is, because here's the last part of today's lab. Now that you've done the plot, you can then fill this in. What's your prediction from the graph? But also now let's go make a measurement of it. And so we've made smaller pendulums, and so we call this extrapolating the data. We've measured the small ones, now we're going to extrapolate it to see what would happen when it got bigger. This is really no different than we did with the air thermometer one, where we extrapolated the data down to where the molecules stop, where we got absolute zero. And so we went from boiling water and then colder ones, and then we continued the line down. So we're going to do that with our graph. And so now that we've done it, let's actually go, and this room is not tall enough for a 3-meter pendulum. And so I'm just going to walk over to the edge here and reset my watch here. And as I walk over here, there is a much taller ceiling. You won't be able to see it from where you are, but it goes way up here. And I have a pendulum right here that is actually tied up to the higher ceiling, and it's 300 centimeters long. So you're just going to have to, I guess, take my word on it, on its length. But I'm going to come over here and measure the period for you. And so I'll just give it a little amplitude here. And I'll just go ahead and I'm just going to measure one swing. And so as it comes all the way over, I'll go ready, start. And when it gets back here, stop. Ha. And 3.53 seconds. Oh. Yeah, that's okay. And then you can hit stop. All right. And that's it.
Oh, that's what's